little review of what happened in the last lesson. So in the last lesson, we were talking about data sets and finding the middle of the data, or what we call measures of central tendency. And there were three important things we learned to calculate. So can you just put in the chat, what were those three things that we learned to calculate? Pop it in the chat. What were the three things we learned to calculate in the last lesson? You guys are on form. Mean, mode, and median. And out of those three, which do you think was the trickiest, or which required the most work to calculate? Which of these three do you think took the most work? Yeah, so I think, okay, so I suppose the mean would take longer to calculate because you had to add everything up. But I think we did the most work with the median. And so today we are going to almost focus a little, well, not just on the median, but we're going to do work that was similar to the work that we did with the median in the last lesson. And so just to kind of remind you of something we used in the last lesson, we called the median Q2, or the second quartile, which will make more sense after today. And we often, when trying to find the median, we actually found the position of the median first. And when we found the position of the median, we used the formula a half times n plus 1, where that was the formula for finding the position of the median, and n was the number of items in the data set. Then once we found our position number, we could then use that to help us find the actual median, or what we call the second quartile. Okay, so that was the last lesson. Now, what are we going to do today? So today, we're going to find basically what's called measures of dispersion, or how spread out the data is. So how spread out the data is. And I want to know from your time in class, have you come across various things that measure how spread out the data is? And if you know, could you put that in the chat? What are some of the things that you've heard about that measure how spread out the data is? So I'm even thinking, I see Q1 and Q3 are coming along, but I was thinking, actually, the simplest way to measure how spread out the data is something called the range. And the range is just the biggest number, or the maximum number, minus the minimum number. So that is the easiest way to measure how spread out the data is. However, it's not the most reliable, but it is something which we're going to talk about today. The other way that we measure how spread out the data is using something called the interquartile range. Now, I haven't even explained what quartiles are to you guys, so we're going to have to kind of give it some time in the lesson today, but often we call this thing the IQR, and the IQR is simply the third quartile minus the first quartile. And another way of thinking about it is, this is the middle 50% of the data. So if we want to know where the middle 50% of the data is, we find the interquartile range. However, in order to find the interquartile range, we have to find this thing called Q3 and Q1. And so we will talk about that to start the lesson today. I see that Kukle is talking about something called the semi-interquartile range. We'll get to that in a later lesson. There are other ways. There's also something called the standard deviation. But for the moment, I want us to talk about the range and the interquartile range. And in order to find these things, we do have to do a bit of work about how do we find these things called quartiles. Okay. Give me a thumbs up if you followed the basic ideas I presented here. Give a thumbs down if you feel very lost. Just want to do a quick little sanity check with the class. So basically what we're going to try and do today is figure out, how do we measure how spread out the data is? And I've given you two things we need to talk about. Now, to start this example, I want to ask the following question. I'm giving you a data set. And that data set, thankfully, is already ranged from smallest to biggest. It's arranged in order. Now, whenever we are doing calculations with quartiles or medians and things, the data has to be arranged from smallest to biggest. For the range, we don't really need that. But in general, in the section, it's always good to have your data ordered. Okay, so the first measure of dispersion. Calculate the range for me. What is the range for this data set? Pop it in the chat. Okay. I see the answers coming through. So we have 25 minus 4, which is 21. Okay, now, next bit. I want to know how many items, or n, little n, how many items are there in this data set? I want you to pop that in the chat. Count for me, how many items are there in this data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 items. Now, in order to find the interquartile range, or the middle 50% of the data, the formula is Q3 minus Q1, but we don't know what those quartiles are yet. So we need to first figure out what Q1 and Q3, and in fact, even Q2 is. So how do we find these things, and what are they? Well, in order to find Q1, what is Q1? It's the first quartile, and it is a quarter of the way through the data. So in order to find the position of Q1, we do a separate calculation. We say the position of Q1 is equal to a quarter times n plus 1. And then we ask ourselves, what is the n value? The n value was 10. And so we go a quarter times 10 plus 1. Okay, let me get my calculator out now. I go 1 over 4 times by 11, and I get the value 2.75. And that value is its position in this list. So let's find that position. Here is position 1. Here is position 2. Position 2.75 is going to fall between these two values. Okay. And so what we do is, in order to work out what the value of Q1 is we say, what is the number in position, well, between position 2 and 3? And I go, well, I just average out between what's there. So 12 plus 13 over 2, and that gives me 12.5. Okay, so that is what's called Q1, or the lower quartile. And what we say is that 25% of the data is going to be below that number, and 75% will be above. Yeah, Emihle, what's your question?
Sir, I just wanted to ask why we used a quarter to find the quartile.
Okay, so what this does is it allows us to only go, basically the Q1 is like a fence, and it fences off the first quarter of data from the next amount of quarters of data. And so the 1 over 4 is just a way of only going, basically 25% of the way through the data. So it is just something that you learn though. Okay, now using the same technique, we are going to find Q2 and Q3. Now, like I said before, Q2 is the median. But what I want you to do is, for each of these, you are going to do the what's called the position calculation, and then you're going to find me the value of the actual quartile number. So for Q2, to find the position of Q2, sometimes people will use a half, or 2 over 4, that's also fine, times n plus 1. to find the position of Q3, we use 3/4 times n plus 1. Now, what you guys are going to have to do is work out the position of these things in the data set. And then after you found the position, I want you to find the value of the second quartile and the third quartile. And then we'll go from there. Okay, Patience, yes. What's your question?
Hi, I wanted to ask, what happens if Q1 is 2,4?
Okay, so what we do for quartiles is if it falls between two values, for the quartiles, we always average out between the two nearest ones. Does that make sense? However, if you got a whole number value, then you would land on an exact number and you would just take that number.
Okay, thank you.
Does that make pleasure? Okay, so you guys are working out first the position of the second quartile and the third quartile, and then you're actually finding me the value of those things. And so let's see what happens in the chat as you go forward and do this. So what's this going to be? So that's 10 plus 1 is 11. So that's going to be 5.5. And then this is going to be so we've got some positions. I want to know what are the actual values of these things. So position 5.5, there's the fifth one. It's going to be between the fifth and the sixth one. So this was Q1. This is going to be Q2, 7, 8, Q3. So who would like to tell us how they got the second Q2 or Q3? If you're willing to share your answer, pop your hand up and just talk us through how you found it, or pop your answer in the chat. I see lots of students are doing that. So remember, guys, that these values over here, the position values, we calculated first, and then we had to get the numbers. Okay, non-causal. Tell us how you got Q2 and Q3. I'm just going to ask you to unmute.
Hi, sir.
Hey.
Sir.
Yeah.
Sir, I did it in a different way though.
Okay, that's fine.
So I found Q2 first.
Okay. Non-causal. I'm
using the Grayton way, taking the two numbers in the middle and dividing
by 2. I think non-causal, unfortunately, the line is very unclear. And so I'm just going to pause for a second. And but thank you so much for giving us, I got the first part of what you were saying, but I didn't quite after that. Patience, yeah.
Would it be okay if I take Q2 as 1/2 instead of 2/4?
Yes. So instead of using 2/4, you can also use, as long as it's a half, you could even use 50/100. So as long as the fraction was equivalent to a half. So what Patience was saying is, can I just say this is 1/2? And in fact, most of the time, that is what I use. Yes.
Oh, all right. Thank you.
You'll still get the same answer, huh?
Yes.
What did you get for your median or second quartile? So what I would do is, to me, it's between 17 and 18. So I divide that and you should get 17.5. So 17.5 would be the second quartile, which is over here. Yeah, and then Patience. What did you get for Q3 or the upper quartile? Try and unmute you there, Patience. Okay, and Keith, maybe we can go to you. Hi,
Hi,
Zuki.
sir.
What did you
Hi.
get for Q3?
For Q3, I got 22.
Yes. And how come, can you explain to us why you have to get 22, even though it fell between two numbers?
I calculated it and I got 8,25. And I used the 3/4 into 10 plus
Yes.
1. And then
Yeah.
I took the two numbers between 8 and 9, 22 plus 22, and divided them by 2, and I got 22.
Yeah. Yeah. So you get 22 because both numbers on each side are the same number, basically.
Yes.
All right. Fantastic. Well done, everyone. Okay, so let's just make sense of this. What does this quartile thing actually mean? I think of the quartiles as fences. And so you only need 3 fences to divide up 4 areas of the data. And so what Q2 is, or the median, is it divides the middle of the data. So below Q2 is the lower 50%, above Q2 is the upper 50%. Now, but at the beginning of this lesson, what I was interested in finding was called the interquartile range. And the interquartile range is that bit in green. It's the middle 50% of the data. So what I want to know from you now is, what is the IQR, or the interquartile range, for this data set? So remember, this is the middle 50%. Now I want you to use what's on the screen and work out for me what is the interquartile range for this data set. Okay, let's do it, peoples. So what is Q3 and what is Q1? That's what you want to think about. So we did hard work and we got 22 was Q3 and Q1 was 12.5. And so in my calculator, 22 minus 12.5 should be 9.5. Yeah. So what does 9.5 actually tell us? It says that the middle 50% of the data sits within a range of 9.5 units. So basically between Q1 and Q3, that's where we squeeze the middle 50% of the data. The lowest 25% of the data is outside that. The highest 25% of the data is above it. But the middle is the IQR, the middle 50%, and we've worked out how to calculate that. So let's do a bit of revision about what the steps we did. We had to know how many items were in our data sets, and then we needed to find the position. And in order to find the position, we used this little formula where each time the number was changing, it was a quarter, then 2/4, then 3/4. And then the final step was to actually find the values from the list. I want to get a quick little vote. Thumbs up if you followed this, thumbs down if you feel very lost, because this is a foundational idea today, and I want to make sure I get as many of you on board the train with me. Alrighty. All right, as Matthew McConaughey would say. Okay, so if you're not there yet, don't worry, we're going to get there. So, quick little revision. The first type of measure of dispersion is the range. I want you guys to find me the range and tell me which of these answers are correct. That's the most basic measure of dispersion, or how spread out the data is. Which of these 4 options? So remember, the range is max minus min. It basically is the whole, how basically it fits the whole data set. It's the range, like how big is the spread of all the numbers. So the biggest number I can see is 91, and the smallest number that I can see is 11. And so we should get 80, which is the correct answer, should be C. Okay, so the range is actually very easy. And the problem with the range, though, is if you have a mistake with just one number, the range can give you a very, very sort of blown up sense of how spread out your data is. And so that's not as helpful. So let's move on to a second example. So in the second example, you're given a bigger data set, and I'm going to count it with you. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So N is 22. They have already showed you in the drawing where Q2 is, or where the median is. You can see where Q2 is. The range, which is not terribly hard, is just going to be 30 minus 9, which is 21. What I want you guys to try and do by yourself now is find me the interquartile range, or the middle 50% of the data. And in order to do that, you're going to need to find me Q1 and Q3. And in order to do that, you're going to have to first find the position of both of these in the data set. So over to you guys. I want to see, can you find me Q1 and Q3 and then find me the interquartile range? Then I know where the middle 50% of the data is sitting. Okay, off you go. Let's be the best we can be. I'm going to grab some water while that happens. And also, guys, while we're working on this question, if anybody's got something they're unsure of, now is a great time to raise your hand, and I'll do my best to answer your questions. Okay, so percentages. So when I talk about the quartiles, quartile 1, so a student has asked about the percentages and the quartiles. Quartile 1 is just 25% of the way through the data. Q2 is the middle of the data, or 50% of the way through the data. And then Q3 is 75% of the way through the data, if the data is ranked from smallest to biggest. So I have positions 5.75 and positions 17.25, but I still have to find my Q1 and Q3, and then ultimately the IQR. 4, 5, 6. So Q1 is going to be there. And then what was this? 16, 17. So Q3 is going to be there. So what I'm doing is I'm using these position calculations to tell me where it is. And now I need to work out what Q1 and Q3's actual value is. And so then after that, I can work out what the IQR is. Okay, so I see answers are coming in. Keep them coming, guys. So Q1 is going to be that, and Q3 is going to be that. And again, notice how with quartiles, if it falls between two numbers, what we do is we average them out. Now, it can sometimes happen that the position is just the number 5 or the number 6. In that case, you wouldn't need to average it out because it falls in an exact position. So this would just be 13.5, and this would be 26.5. So the interquartile range, I want to know in the chat, what is the interquartile range? Keep them coming, guys. Keep them coming. So we know what Q3 is. So there's Q3. And the interquartile range, I should subtract Q1. And so the interquartile range is 13. Fantastic. Now, what does that actually mean? It means that the middle 50% of the data is sitting within a range of 13 units. And what you just found was that that interquartile range was 13. It basically means the whole 50% of your data is sitting in that amount of space. Now, it takes a while to get used to the ideas, but my main goal today is making sure you know what quartiles are, how to calculate their position, how to find their value, and then knowing how the quartiles relate to the interquartile range and what that means. So before we take a break, are there any questions? Or I know this is a bit weird the first time you see it. So if there are questions, now's a great time to send them through in the chat. Otherwise, we're going to take a little break because we've done well in this first part of the lesson. I'm pretty chuffed. So are there any comments or questions from the students of the house? Right. Well, then what I'm going to do is I'm going to say to you guys, I want you to stand up, turn your cameras on. We are going to do a little stretch. And Lebo, if you could please encourage our students to just, like invest in themselves by stretching it out. I will do the same. We need to take care of our brains. And that means just stretch it out.
Come on, guys, you deserve this stretch.
Maybe somebody can do a little, like I was thinking we should have a few dance moves that we learn on our little stretch, but maybe some of the students can teach us with a little something, I don't know. I was watching a Bollywood thing on YouTube. I was like, maybe we should learn some Bollywood moves to go with our stretching time.
That would be awesome.
They go like,
oh yes.
And they do that
like
thing with their wrist. They're like, yeah. Whatever works for you guys.
Good on, guys. I see Lusanda, Walter, William, Nolwazi. Lesukho's bringing some dance moves.
There we go. Whatever gets your body and your brain to be relaxed, right? So silly is your friend in this case. We've been being so serious for half an hour. Your brain is craving, like, give me a joke, give me some freedom, give me something to just chill out a bit.
Let me breathe.
Exactly. Okay. Siwe, I'll definitely come back to you in the next part of the lesson. We're going to practice this some more. And why did I say 12 plus 15 divided by 2, not 15 and 18? Let me just check that. 1, 2, 3, 4, 5. So to answer your question, the quartile 1 is in position 5.75. So if I count 1, 2, 3, 4, 5, 6, my position is between the 5th and 6th position. So that's why I added 12 and 15, just to respond to your question there. Okay, let's do a little brain break. The brain break is as follows. I want you to find how much is that triangle worth? How much is that triangle worth? So you've got this thing at the bottom and your brain is saying, please give me something novel to do. So we're going to give it something novel to do. Oh, thank you for helping out there, Cameron. I see you've been alert in the chat there. That was awesome. And guys, it's a really well-known fact that if you teach other people something, as you do that, you start to understand it even more deeply than you would if you were just learning it. And so if you've got something to add in the chat to help a student, please do feel free to do that. Okay, so what do we got here? We're looking for a triangle value, and we need to figure out, well, I think this has to be 5. So Teddy's got an answer for the triangle. Does anybody, let's see who else has an answer. So I know that this must be 5 and this must be 5. Okay, so there's a couple of different answers here. So let's see how we get this. So I was thinking this Kuchle, also, I think I agree with you. I think if that is 2, 5 times 2 is 10 plus 2 is 12. So this would be 2. And we also know that this has to end up being 5. So then the question is, what is the triangle going to be? What is the triangle going to be? It's going to be, well, 5 times 2 is 10. And it have to end up with 5. The triangle has to be 1. Because the only way you'll get 10 minus something times 5 is 5 is if that thing is 1. Yeah, there we go. Awesome. So the answer to today's brain break is equal to 1. Okay. Let's get back to the types of questions that we were doing today. So I'm going to ask you a multiple choice question now. So I'm giving you, these are actually in the wrong order. So let's not do that because it would take, okay. We're not going to do this question because it's going to take too long, but I just want to point out to you why it will take too long. If you look at this data set is not arranged from smallest to biggest. Now, if it's not arranged from smallest to biggest, it means that you first have to order the data. Then once you've ordered the data, you can do the calculations and so on. But because of limited time, we won't do that. But I just want to point out to you that the data must always be organized from smallest to biggest when you're finding the interquartile range. So let's go on to this one. I want you to find me Q1, Q2, and Q3, and also the range and interquartile range for this data set. I will help you count to start with and get what n is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so n is 19. I want you to find me the quartiles for this data set, and then I want you to find me the range and interquartile range. Off we go. So I'm going to give you a fair amount of time for this because I know it takes some work. And I want to encourage you, because of later things that we know, start by finding yourself the position of these items in the list and notice how the data is arranged from smallest to biggest. So that's a good sign because it means that we can do these calculations. So what did I say n was? It was 19, huh? Okay, so keep those answers coming. And so for those who maybe always need a bit of assistance, notice how I found the positions of the quartiles in the list. And this time they're not decimals. So they're actually just whole numbers. And so I'm going to count, where is position 5? Or where is, it's going to be, let's get my highlighter, 1, 2, 3, 4, 5. So since this is position 5 in the list, this is going to be the value of Q1. It's going to be 9. And so we can even put it here. This is Q1. The median for Q2 is in position 10. So let's find 6, 7, 8, 9, 10. So it looks to me like Q2 is going to be 16. And that would be this one here. And this time it's not falling between numbers, it's exactly on numbers. And then 15, so 5, 6, 11, 12, 13, 14, 15. It's going to be here. So that's Q3. And so this is going to be 21. So 25% of the data is 9 and below, and 50% of the data is 16 and below. What is my range and interquartile range? So I see interquartile range, lots of people are saying 12. Let's check. So for the interquartile range, it's Q3 minus Q1. So it's 21 minus 9, which is indeed 12. And the range is the biggest, 32, minus the smallest 2, which is 30. Yeah. So what does this say? Well, it says that the whole set of data lies within a range of 30 units. The middle 50% of the data, which is sitting over here, lies between 9 and 21 in a range of 12 units. Okay, Leleta has asked how you got 9 for question 1 because I got 8. Okay, so this is very important and it's a great question, Leleta. So I just want to, because a lot of the time up till now, I've been finding the Q1 between the two numbers. Now, what's very different to last time is the position of Q1 is no longer a fraction. It's not 5.5, it's a whole number. And so all I do is I count, that's 1, 2, 3, 4, 5, and the number 9 is in the 5th position. In the previous question, the numbers fell, if you look at how I calculated Q1, Q1's was in position 5.75, which meant it fell between two numbers. Whereas in this question, it was an exact value. So I hope that helps you understand that thing. Now, I want to ask you guys to do something new now. I want you guys to calculate what's called the semi-interquartile range. And all you need to do to get the semi-interquartile range is take the IQR and divide it by 2. So I want you to find me the semi-interquartile range for this particular question, knowing that the formula for the semi-interquartile range is just the interquartile range divided by 2. It's kind of boring, it's so simple, but you know what let's just make sure you've seen this before. Okay, so semi-interquartile range is just 12 divided by 2, which would be 6. Okay, so what have we done today? We've learned about quartiles. We've learned about trying to say how spread out data is. And we've learned about these things called the range, the interquartile range, and the semi-interquartile range. And these are all foundational ideas. Okay, so Asanda, semi-interquartile range is not as common as interquartile range, but it is something which is used as a measure of spread sometimes. Okay, let's do some multiple choice. In fact, before I move on, are there any questions or comments about this example?
Mr. S,
Yeah.
Hello says that he or she got 9.5 for Q1 and 21.5 for Q3. Could you quickly please explain again?
So this was just about the idea that we have exact. So if we look at our position numbers, you'll notice in this example, we have exact numbers, which means we go to literally for Q3, we go to the 15th position in the list. We don't go like between two numbers. So if we count to the 15th position in the list, I'm literally just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so Q3 is the 15th position in the list. And that corresponds to that 15 over there. But the value is 21 of the number in that position. Okay. Let's do this. This is a multiple choice question. Find the lower quartile of the following set of scores. I want to see if you can do that for me. Pleasure, pleasure, pleasure. So I'm first going to check, is the data in order? It is. 1, 2, 3, 4, 5, 6, 7 data items. Position of Q1 is a quarter times n plus 1. And n was 7. So a quarter times. So wait, it's going to be 2. And so position is going to be, sorry, not position, Q1 is going to be in position 2. So what is the value of Q1 in position 2? It's going to be, so that's position 1, that's position 2. The answer is going to be 7. Yeah, wasn't too bad. So in this data set, it's a very small data set, but we know that 25% of the data is on or below 7. Cool. Oh, that was pretty good. I want you to find me the upper quartile, or Q3. Sive, I have a question. What if are the letters mixed with numbers? Could you maybe be a bit more a question? What if the letters are mixed with numbers? Okay, so find the upper quartile for this data set. Awesome, Walter. I like to hear that. Just keep practicing and understanding will keep increasing, I promise. There we go. Now, the one thing I want to point out, and I was a little bit sneaky, is this data is not arranged from smallest to biggest. And so when we find the quartiles, we always assume the data is arranged from smallest to biggest. So I threw that in there to see. So 6, 140, and then 150, and then 150. And in this data set, there are 6 items, or n is 6. So what is the upper quartile? Well, the position calculation is going to be n plus 1, which is going to be 3/4 times 7. So what's that position going to be? So this position is 5.25. So which list are we going to be looking at? We're going to be looking at the ordered list. So in this case, 1, 2, 3, 4, 5. And it's a bit weird, but basically, but 5.25 is between these two numbers, which means that, and this is a very weird scenario, but basically Q3 is going to be the average of 150 and 150, which is just 150.
Good
So
job,
I was just
guys.
testing you. Yeah, that was a sneaky one. But I think most of our students are feeling okay there.
Mr. S, not
Yeah.
sure if you understand Siwe's question in the chat there.
So will there be a time when there'll be letters and then I'll have to find the value of that letter? I don't think so. You would normally have to convert letters or qualitative data into numbers, like counts of numbers or categories. So Siva, I don't think that's a possibility the way I understand your question. Okay, last question of the day. Find me the interquartile range. Now, this is a very weird, it's a very small data set, but let's just see what we can get. Find the interquartile range of the data there.
Mr. S?
Yeah.
Nolutando is asking if you could please repeat why Q3 was 150 in the previous question.
Okay. So, Nolotando, if you look at the way I found my Q3, I started by doing what's called the position calculation. And so I went Q3, the position of that is 3/4 times n plus 1. Oh, I see which 1, 2, 3. Yeah, so now I get that. I then put n is 6 into this calculation, which is over here, and that's why I get 7. Then the position I got was 5.25. If I go to my list, position 5.25 is actually going to be between these two numbers. And so that's why I have to average them out. I basically have to go 150 plus 150 divided by 2, which is going to give me 150. And that is why it's Q3. Just want to check the answer. Okay, pleasure. A quarter times n plus 1. Now, n plus 1 in this case is going to be 6. And in this case, n plus 1. So that is going to be, what's this? 1.5, 4.5. So position Q1 and Q3. 1.5 is between the first and second position. It's over here. So I go 20 plus 22 divided by 2 is 21. And then the position of Q3 is 4.5. So it's between here and here. So that's going to be, make sure I'm not going too fast, is 30. So what is my interquartile range going to be? It is going to be 30 minus 21, which is 9. That's it. All right, my people, I thought that we made good progress today on understanding quartiles and the interquartile range. And so what we're going to do now is Lebo is going to put a link to a quiz that you guys can do to just check that you've understood the stuff that we've done in the first 2 lessons. And yeah, I want to encourage you. I think you've done very well. And if you keep building your knowledge in the section, you'll find that there's some really easy marks in this section, but you just have to build up your understanding gradually. Okay. And yeah, let us know in the chat what was good for you today, what was bad for you. Because we don't always see you like in a regular classroom, we really rely on you sharing with us. And so feel free to share as you finish off today. Yeah. Thanks, Cameron. I'm glad you enjoyed the lesson.
You're welcome, Cameron.
Enjoy the quiz. Enjoy the quiz. Are there any other questions from students before we finish off for today? Oh, I'm so glad, Asanda. I'm so glad, Kukle. It was lovely being with you guys. It's nice to feel like we're helping. I don't know what you think, Lebo, but it feels good to feel like we're helping students.
Definitely a good feeling.
Yeah. All righty.
Thanks, guys. See you again on Monday.
Enjoy the quiz.
Please do the quiz.
Yeah, do it now. It's a good time to do it now. Yeah.
Yes.
Pleasure. Okay.
Mr. S, do they usually ask for the semi-interquartile range in exams? Question
They do
for the chat.
sometimes, but it's more common to ask about the interquartile range. Yeah.
Okay.